Okay, I'm answering question number 5. A mass of 12 kilograms is placed on a table. A string is tied to the mass and run over a pulley to a hanging mass. The coefficient of static between the mass and the table are 0.342. No, sorry. The coefficient of static friction between the mass on the table and the table is 0.342. What is the minimum value of the hanging mass that will start the system moving? Okay, so I'm just going to write down what we know. The given, we know that mass is equal to, the mass of the first crate is equal to 12 kilograms, and that we know the coefficient of friction equal to 0.34, and sorry, got some rough notes under here. I'm just going to erase this. And we know that the mass of the second cube has to overcome the force of friction. So right now we know that the total, the net value of the force is equal to 0, and that means the two forces that are acting on the system right now are the force of gravity and the force of friction. And right now we can set those two things to be of each other because that's just how it. Because the system's not moving, we know that those two are equal to each other because they act in opposite directions. So we know that the mass times the gravity is equal to the coefficient of friction times the normal force of the weight that we already, or the crate that we know of, and then so we have mg equals the coefficient of friction, and then we know that we still need to find this mass. On this side is what we're looking for, is the mass on this side, and we have the coefficient of friction over here, or we have it equal to coefficient of friction times the normal force, and we know the normal force is mass times gram, so we can have U times mass times gram, and then we can cancel out the masses here. No, the gravities. Sorry, was I saying gram the entire time here? I meant to say gravities. Mass times gravity. So right now we have m equals U times the mass, and this is the side. This mass is the side that we know, so it becomes 0.342 times 12, because it's 12 kilograms. Is that the crate we know? And that's the mass right now that the second crate or second box is, because it's not moving. And if it was any lower, it would be moving up, and if it was any higher, it would be moving down. So let's find out what it is. 0.342 times 12 equals 513 over 125. It's not what we want. 4.104 kilograms is equal to the mass right now. So anything above that is will get this system moving. So that's what we need. I'm just gonna write that down. Therefore, it must be larger than 4.104 kg. Perfect. Thank you.